Okay, welcome to day two, day three. In day three, we are going to cover a few topics. One of them remaining from yesterday, VLT, and then we need to talk about some security mechanism, a feature called VLT, VRRP protocol, OSPF, BGP, and VRF concept, quality of service, SNMP, RESTconf API, and finally the concept about VXLAN. So let's start with the VLT, this topic that was remaining from yesterday. We call it virtual link trunking. This is the meaning of VLT. And if you work with Cisco switches, you will find, especially here, NXOS, the 5K or 7K, you will find that there is another name for it. We call it Cisco VBC, Virtual Board Channels. The concept is simple. And I must say the configuration in OS10 is also straightforward, not complicated, unlike some other vendors. Normally, you could have two switches, OS10 switches, and these two OS10 switches are actually just the virtual machines in a data center. And we have, let's assume that we have a physical switch here. And this physical switch need to be connected with these two switches with board channel. And when it is connected to these two switches, since it is two virtual machines in data center, it will be good to deal with them as a one device. As a one device from the perspective of this switch. Let's assume this is switch number 3. So switch 3 will look to these two switches like a one switch. And that's mean if you want to have a board channel link, he will have one link connected to each one of them. But from his perspective, from the perspective of switch 3, he is like connected to one switch with two board channel links. But this is the logically, but physically, he's actually connected to two switches, and these two switches is acting like a one switch for switch 3, and he will be connected with one link here, one link there, and actually these two links is board channel for the switch 3. And again, from the two switches inside the data center, it will be also a board channel links. This is simply what's happening, and this is what you can see even in Cisco. The two switches are here. Here is switch 3 in our example, and this is the board channel two interfaces. There is something important should happen here, that these two switches should have two links to communicate with each other and synchronize each other. This is what we call it VBC pair link. And normally these should send to each other keep alive messages. Keep alive messages cannot be sent in these two links here. So they will be connected to a network, let's say 10.0.0.0, and they will keep sending their own keep alive messages through these other links. This is what we call it keep alive link. And these two switches with these two links in the middle, with each one of them has a board channel link connected to this physical switch. All this is represented in what we call it VBC domain. This is from Cisco perspective. Now, and as you can see here, also we have the same thing, maybe some extra information that you could have. This is orphan board. So orphan board means he's not connected to a VPC link. In VLT from Dell, we are doing the same thing in this way. The terminology that we are using is different a little bit. Instead of saying VPC, we are saying VLT. So we have the VLT domain. The two switches or the two VPC devices, here we call them a VLT pair device. The VPC links that make these two switches connected to each other and synchronize each other, this is what we call it here, VLT interconnect VLTI. So this is the name of this link and this link. The name of the interface itself in each switch, here, 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 here. These interfaces, we call it discovery interface. So let's assume that I have Ethernet 1111 and 1112. These two switches for this device, let's say this is device 1, this is device 2, we call them discovery interfaces. In the same time, they need to make sure they are online, so they will use, they will send to each other a keep alive message. And this keep alive message that it will keep sent every few seconds, it will not be able to be sent in through these two links, the VLTI. So we need a link, connect them to a network, let's say 192.168.100.0, and both of them should be able to communicate with each other and send keep alive message through the connection of this network. And this keep alive message here in the terminology of Dell solution for VLT, we call it backup link. So I have a backup link in this VLT pair device. I have a backup link in this VLT pair device. And normally we use the management interface in both devices to send this keep alive message and to be used as a backup link. So in normal cases, backup link is your management interface in Dell switch. In the same time, I have one interface here, VLT interface, that's going to be communicating with our device down here. And I will have a VLT board channel. In another meaning, I'm using LACV, which has the IEEE code 8023AD. And that's it. This is simply the VLT. From that perspective, from server perspective, or from any device here perspective, he's like connected to one switch with a virtual two interfaces acting as a board channel or VLT board channel. For him, for this device, it is just a board channel. You don't even care about or know that this is a VLT board channel. But from the perspective of this switch, we know that we have two devices and we are running VLT to make this topology that we can see here happening. Just wait a minute. So VLT is a layer 2 aggregate protocol between end device servers normally connected to a different network device. Not necessary, you could also have switches. VLT instead of servers. VLT reduced the role of spanning tree by allowing the link aggregation group. Actually, yes, this is what board channel is doing. Configuration for VLT in both sides should be the same. In another meaning, the configuration that I'm going to put in VLT bear device here and bear device there, 1 and 2, should be identical. I cannot add one extra command here and I don't have it in the other side. .1x, DHCP snooping, MST spanning tree protocol, any in-out quality of service are not supported in VLT boards. So these things, I cannot use it in this solution when it comes to the board that act as a VLT board. .1x, DHCP, and this is something makes sense why I will need .1x with the switch, but maybe I will need it for sure with the server. So to authenticate the server itself as an endpoint and the user or the admin sitting on it. But you will not be able to have these few features there. All these components, which is include the VLT boards here and the discovery interfaces here and here, the backup link. All this is existing in what we call it VLT domain. So, and any VLT domain will support two devices, two node members, so one pair. They will appear as a single logical device. Each VLT domain will have a unique MAC address that you create or that VLT create automatically. What does this mean? Means simply that for this device here, let's say server or something, he's seeing these two switches as a one switch. And normally I need a MAC address to represent each switch. And we know that we have two switches actually physically in our physical topology here. So this MAC address, normally VLT feature will create a virtual MAC address for you. For best practice and to help you later in troubleshooting, sometimes we can say that you can give this MAC address by yourself. You can create it, or you will leave the VLT to create it automatically for you. It is optional thing. For our VLT domain, there is a VLAN. They will act on it, and VLAN 4094 is reserved for any internal control messages. ARB, IP version 6 neighbors, MAC address table, all this will be synchronized between the two switches using our VLTI or VLT interconnect links. VLT bear devices operate as a separate node with independent control and data plane. Okay, physically, both of them has his own data plane and control plane. While for this device, he's dealing with it like one switch. So he's thinking that this device has one control plane, which is normally mean your protocols, spanning tree protocol. It is good to run it here to avoid looping for sure. OSPF, any routing protocol. This is what we have in the control plane. And I will say that I have one data plane. This is the part of my switch brain that's responsible for access control list, quality of service, any other things. And normally the decision in data plane talk from the first place from what control plane decides. So control plane normally will decide which path we will take based on the bus path, based on the routing protocol or any other switching protocol I'm using. Then I will start handling the data in data plane and try to send it. So I need to apply some feature maybe configured in my device, like access control list, quality of service, and these stuff. This is the story of control plane and data plane. And you might, in day one, when our colleague was talking about software-defined network, maybe you notice that software-defined controller is trying to separate the control plane from data plane. But anyway, here in VLT, when it comes to control plane and data plane, we need to remember that each switch has his own control plane and data plane. So they are not acting, yes, they are appearing like a single switch, but physically each one has his own data plane and control plane. Even if they are in this VLT interconnect link, they are synchronized, the ARP, IP version 6 enables, MAC tables, and so on. One of these two nodes, one of these two switches will act as a primary, and the other one will be a secondary. So one node in the VLT domain will be primary role, and the other node will be secondary role. So one is the master, and the other like a standby for him or a slave. Which one will be the primary? The one with the highest MAC address. So in the end, this one has one MAC address, represent this switch, one MAC address represent this switch. The highest one will be the primary, and the other one will be secondary. For this device, he don't see these MAC addresses. As we said, he is saying, or he's dealing with virtual MAC address. That, as I said before, you can create it by yourself, or you can leave it to VLT to create it. In VLT domain, we have one important condition. Both of them should run OS10. So OS10 software version must be the same. In another meaning, we cannot have here 10.4.1, and they can have here OS10 5.1, for example. This will not work, and we will not be able to have our VLT bearer devices up. They should be running the same OS10 software version. Now for the link, the two links here, the VTI links, as I said, in our build devices, they will synchronize the states and the ARP, MAC tables, all these things. As I said, these two interfaces here, they will use VLAN ID 4094 by default. Configuration is very simple, and I must say that if you go to in the demo site from Dell, I know that few of you are using it. In the getting started guide, you will find a good lab for VLT. Two switches will act as a one domain, switch 1, switch 2, and switch 3 will dealing with switch 1 and switch 2 as a one device, and feeling that he's connecting with them with the port channel normally. Here in this example, they showing you that the Ethernet 11112 is the ones that we are using here, and in switch 2 to have the VLTI link. Board channel is a trunk and is going to support or allowed VLAN will be 200. Then they will start showing you the configuration. From configuration perspective, switch 1, you will give it IP address in the management interface. Management interface will be 192.168.122.2. This is in switch 1. Sorry, this is for, so we have here a management interface. And our management interface in switch 1 and switch 2 will be used to make them communicate with each other as a keep alive link or backup link. This is the name of it in VLT, backup link. So we are configuring the management interface here if it's not configured before, because we will use it as a backup link later. Then I'm going to the interfaces. I'm saying no switch port 111 and 112. Then in switch 1, I'm creating my domain. And as you can see, I'm giving a number to my domain, VLT domain, and just a number. So that's mean the domain representing these two switches is domain 1. Discover interfaces, and for switch 1, it is going to be interface 111, 112. So I'm telling my switch 1, these are your discovery interfaces. Optionally, you can give the MAC address by yourself, a virtual MAC address to represent these two switches as a one switch, or leave VLT feature to do it for you. So this command is optional. But as I said, it's best practice to do it by yourself. So VLT MAC, and you will give the virtual MAC address. Then you need to tell me in the domain, what is the backup link? My backup link destination, the other side, has this IP address. Remember that here, we said my management interface is 192.168.122.2. So that's mean I have this IP address here. 192. And this guy has the same IP address, subnet mask, subnet, but in the last octet will be 3. So they should have a connection between them, and they can ping each other. Now in the switch 1, when I want to talk about to configure a backup link, I will not say, hey, your management interface is backup link. No, I'm talking about the destination. So I will tell switch 1, your destination for as a backup link is this guy. And I will do the opposite in switch 2 for sure. So here I'm telling him that our backup destination is .3. Then you will normally create your VLAN, create your interface board channel. But when you create your interface board channel, you need to add something, that our interface port channel is belong to VLT board channel 10. So actually, this is not a normal board channel, interface port channel. No, it is a part of VLT solution. And in this case, I'm typing this command under the interface port channel, VLT board channel 10. For the physical interfaces, I will run the active, passive, and all these stuff. And that's it. I will not go for VRRB now. This is completely optional. Okay. But since we didn't talk about VRRB, I will leave it right now. And that's it. This is the configuration that you need to do. You can type show VLT1, and you will find what is your domain ID. You can find the role, secondary or primary, and it looks like our switch 1 will be secondary. Why is that? Because his MAC address is lowest than the switch 2. Something worth to mention: the role itself Yes, we choose it using the MAC address, but also we have a priority, and you have a command for that to change the priority if you want to force switch 1, for example, to be the primary. The virtual MAC address, IP addresses in version 6, whatever, what we have here, and 2 devices in our network. This is device 2, I'm device 1, and which is here in our example switch 2, and he has this MAC address, and we can see that from this octet, or yeah, from the 3rd octet here, this one, we can see that this one is the highest MAC address, so he will be the primary. This is show VLT1, and that's it. You have also show VLT1 VLT board details to see that your board channel is running. Normally, the good thing that if you go to any switch and type this command, he will show you the board channel interface in each unit, in each switch. We have unit 1, unit 2, switch 1, switch 2, this is how he named it, and they are up, and the configured board is 1, 1, and they are active. So from anyone, these 2 switches, you can see if the 2 linked board channel here and here are working fine, and everything is working good. So simply, this is one of the labs that you can have. Later, you will see that in Dell documentation, they will keep talking about what will happen if we want to add some extra feature to this solution, like VRRB, like VRF, and so on. And you will find it is actually not a big deal. Command itself, as you can see, VLT domain 1, discover interfaces, the MAC address, virtual, if you want to do it manually, backup destination, under the interface board channel, 1 command only, and mostly that's it. Everything else is a normal board channel configuration. As I remember, yeah, failover time is 90 seconds. For sure, if you work with Cisco, you have more commands to type than these commands in the beginning. That's why I like the VLT in Dell, because we don't have a lot of commands and configuration to make this solution happen. That's it for VLT. Something worth to mention here before we continue, since we was talking about VLT and VBS, VBC from Cisco, virtual board channel in Cisco and VLT, virtual link trunking in Dell, both are the same, but for sure you cannot mix between them. There is a good file. I will share it with you. You can download it easily from Dell documentation library here. I will share it in the chat. This is like a quick guide. This is a quick guide for configuring OS10, 45 pages only. And the good thing in it that in the end, in page 36, he's showing you connecting Dell EMC to third-party switches, normally Cisco Nexus switches. and you will not find something hardly. Board channel, he's showing you the configuration and board channel in Dell EMC switch and in Cisco Nexus switches. As I said, you will not find a lot of things. Just remember something that when we was comparing always the normal traditional skills that any network admin will have when he was dealing with multi-layer switches and so on, but in a campus case. But when it comes to data center, normally we are talking about Nexus switches and from Cisco, like 5K, 7K. And normally these are using a different operating system, not iOS. It is using NX OS. And for sure, with software-defined solution, we have something else. And this will make maybe these Cisco switches not in the market, like after 4 years, 3 years from now. I don't think if we will have it in the market. But anyway, till now we have it in the market, and they have their own operating system, NX OS. As I said, like Nexus 5K, 7K, some 9Ks, they are using also this NX OS mode. We call it. We have ASI mode and NX OS mode. For this one, you will find that, for example, if I want to run a feature, a routing protocol like OSPF, like board channel protocol like LACB, you need to type the command feature. That's why you will find here the command feature. This is the different things that you will find it, but actually anything else is similar. You will find also showing you the show command in both devices. In VLAN, how to create a VLAN in Dell switch and configuring VLAN in Cisco Nexus. Assigning access port to a VLAN in Dell and assigning it to Nexus switches. They will keep showing you till the end of this 45 pages what you can do with Cisco switch and what you can do with Cisco Nexus switch and not any Cisco switch and Dell. When they are not comparing to show which one is more better, but actually they are showing you how to make them talk to each other and work together in the same environment.